Right, perfect. So our purpose as a company at Verge is to accelerate the transition to autonomous farming. We see that as a multi-step process, and we're at the end of the first step of that process, which really is if farmers have to adopt autonomy, then the first thing we need to do is reduce the decisions that they're making in field. So in the paddock, a lot of decisions are being made quite often by the grower and the operators, unless those decisions are brought forward back into the comfort of their office or home while they're planning. It's going to be really hard to make that shift to autonomy. So that's our product vision right now, which is reducing in-field decisions. And what we've built is a product that takes a user through different boxes here. And what we envision is a workflow that's new. We're calling it the path planning workflow. It starts with a plan. That means interacting with the digital format of those fields, like Ian mentioned, simulating all the potential options of machinery movement for a specific operation, analyzing the data that comes with the summarization of how a machine would perform in terms of number of passes in the field, or reducing erosion, reducing wheel traffic area. So analyzing all that data to arrive at one particular coverage pattern that is optimal for the grower, and then executing on that plan. And after executing, you want to validate in-field or in-paddock performance with how it was originally planned. Look at ways you could improve. One of the gentlemen talked about removing the fences and bringing a couple of those paddocks together to create one larger paddock. Updating boundaries to be more accurately mapped based on RTK. And then continuing to improve the planning, which is looking at improving the fleet, machinery fleet. So we have a way of simulating the paths each machine takes. So you could simulate not just the a new sprayer that you want to buy going wider with the boom, or you could look at the analysis of implementing section or row control on that boom versus having no section control or row control. Same with seeders and harvesters as well. So improve your operation, come back in and plan again. So that's kind of that new thinking model that we're bringing to everyone's planning cycle through this product. So when we start with the first box there, which is really plan, Ian covered most of this in terms of, everything starts with a boundary, right? So we have multiple ways boundaries can be imported into our platform to create run lines. The most efficient way is to use our integrations with one of these OEM providers. So we are integrated with John Deere's Operation Center, CNH's new platform that's been renamed from AFS to, I believe it's Fieldworks or Fieldworks. And then Trimble as well has a platform that allows you to easily bring in boundaries that are already in the system into ours. It kind of works as a single sign-on, so you don't really need to create a native Launchpad account. You could just authenticate against your credentials on one of these platforms, and then we would automatically bring in the boundaries. If you don't have an account with any of these connected OEM cloud platforms, you could also import shapefiles of your boundaries from any other software that you have. You can hand draw the boundaries on our map layer. Obviously, that won't be very accurate. Our map layer is a simple map layer that's publicly available, so it won't be to the precision accuracy of an RTK mapped boundary. We have fairly better boundary selection than hand draw, which is you could select boundaries from one of the satellite data sources that we're using. So we're basically leveraging satellite imagery to delineate the fields. And then as you zoom into a particular area, you can pick the fields or paddocks that are yours and create a farm that way. Again, that is not very accurate. It's based off of imagery, always the accurate ones are going to be the ones that are mapped using RTK and imported from one of the OEM cloud platforms or imported as a shapefile into our system. These boundaries can, of course, be edited. You can create zones, modify internal obstacles, mark them as passable, impassable, and so forth. So ways that you can interact with the boundary, but obviously our preferred method is that you bring in that through one of our OEM integrations. The next step, as I said, is really simulate. So once you have a boundary and you enter your equipment parameters, which is primarily the speed of operation, your working speed and turning speed, and then the width of the implement, whether that's a seeder, sprayer, or the harvester, then in that case, we would create a path plan. So these are the different layers of plans that are available for one to do further analytics. So at the bottom is the field geometry layer, which is the boundary. Based on that boundary, we source the topography information, and we have this worldwide. It is not of the highest resolution. It's available from NASA DEM. We do some super sampling to bring it to a higher resolution, but at least it's available worldwide, and the users don't have to import their own elevation data, right? So we bring in the topography through publicly sourced data. You review a path plan, which is a basic plan, straight tracks. Based on the topography information, you can bring in the slope layer. So if you want to optimize your run lines based on minimizing your travel up and down a hill, and you want to travel more on flatter areas, then we do bring in the slope layer that gets built on top of this path plan and tells you how much percentage of your travel you can minimize over a certain grade slope, and maximize over 0 to 1% slope. So you want to travel mostly in flatter areas. So it gives you a direction that minimizes soil erosion. So we have a metric called soil erosion potential that uses a revised universal soil loss equation to model that using the topography layer and our path planning layer. So it becomes very easy for users to go, okay, I want to reduce erosion. What's the coverage pattern? So it gives you the heading and the set of tracks associated with it. You could change that into, okay, I want to minimize the number of passes in the field. It gives you a different optimal. And for each of the tracks, you can also switch on the coverage layer. So this is planned coverage to see where exactly your overlaps are or where your misses are going to be based on the coverage pattern that you've chosen. Based on that, you could potentially decompose the field into multiple parts and have localized path plans for each part or each subpart. And then finally, you're able to create a full route within our system as well. This is still in early stages of development. You're able to visualize the route. We have modeled some simple turns. Obviously, we want to get into more sophistication around that as we can model different types of turns that growers do in the field. So that's really the simulation aspect of it. Once you simulate it, you really want to analyze the right option, right? As I said, there's different things you can analyze. You can analyze the elevation information to minimize soil erosion, or you could analyze wheel traffic area, which is quite prominent in Australia as you're looking to go towards more controlled traffic farming. In this case, you can calculate the wheel traffic area for a single operation, but you can also bring in all of your operations, so seeding, multiple spraying operations, harvest, soil preparation, all of that, and see, okay, what's my wheel traffic area for an entire growing season? So in this example, you could see that the wheel traffic area for harvest is just 6.4 hectares, but then for the whole season, it's 10 hectares based on the equipment in this kind of case study. So they don't technically have the exact denomination of the width between all equipment. So it's a way for users to analyze what's the most optimal way to deploy their machinery to minimize wheel traffic area. And similarly, you could go, okay, I want to minimize overlap in my fields, or I want to minimize time I spend so that I want to get this operation done as soon as possible. And for each of these options, once you analyze and save, then the next step is to actually execute in the field. So we have multiple ways to get the final plan onto the machine. One is obviously through our integration with the OEM partners, as I mentioned. So you can push path plans and export it to John Deere's operations center, or export it to any of the Case and New Holland machine formats, even supporting the latest monitors for both Case and New Holland and also Trimble. Similarly, ISO XML kind of works with most machinery that are non-John Deere or CNH or Trimble, like any of the AGCO machines. I think even CNH and John Deere also support ISO XML, so that's another format in which you can export this path plan. You can download it and upload it to the display, or you could, send it to John Deere's Operations Center. Currently, that's the only operations platform that supports the intake of a path plan through APIs. I'm sure Case and Trimble are also working on that, so that'll be up here soon as we build that integration. And then finally, there are different object types that you can export. You could export an AB line, just an AB line. And as Ian mentioned, people go through different naming conventions for those AB lines. We actually take care of that naming based on the field operation and our software, so that naming is automatically assigned. So you can actually see it on your display what exactly that AB line was that you created using our plan. Similar to AB lines, you can also choose to import all of the inner tracks, so not just the AB line. So all the straight tracks, the curved headland tracks, so the perimeter passes, the outer boundary, and also we do import, help you export the inner boundary, which is basically the section control boundary for your operations. The benefit of doing inner tracks and perimeter passes is it allows you to execute the inner tracks first and then come back and do the perimeter pass, which is also exported as a curve, adaptive curve. And in this case, you would do less of seed bed disruption, especially when you're seeding. You could actually execute the inner tracks first and then come back and do the perimeter passes. The operators can, obviously visualize these tracks on the display in the machine itself, or they could also see these plans on a mobile device. So we allow sharing of this plan with operators or advisors or even farm managers or anyone else within the farm that needs to know what plans are associated with each of these paddocks. So you can export plans of all of the paddocks and share it with anyone, and they can pull it up on their mobile device without logging into the software. So it's just a link that you can see on the browser. And we've just recently released a new version where you're also able to collaborate with the operators and see if the operators are actually following the plan. And you can see that on the mobile device. So as long as the operator enables location sharing, you'd be able to see a shared plan on the operator's device as well. And the operator can kind of see, okay, am I always entering from the north side and going south side? Then let me, making sure that that's being done operation after operation, rather than coming in on the south side the next time and going north and ending up with all the turns on the north side and trampling crops on both ends by the end of the season, right? So this ensures that a particular plan and direction are chosen all the time. So that's the execute part. I know I covered quite a bit. Hopefully, within the next webinar, we'll be able to showcase the app for you, but you don't need to wait till the next webinar. You can easily go to our website. It is vergeag.com, and you can click started, create an account, and it's a completely self-service app. If you're not able to get started, then clearly we have failed in our mission to develop a very self-service application. So please do sign up for an account, and or reach out to one of our partners in Australia, like Ed, Michael, Bindi, and
you're on board.
Alice, Christian, any of them, and they'll be able to support you with setting up your farm in our Launchpad platform. That's all I have.
Thank you very much, Godard. That was an excellent introduction to Verge, and I think does really link in how the importance of getting those boundaries right initially to get the most out of Verge. I think it certainly makes sense. There was a question that came in from Emma of just how many farmers are using Verge currently, and of these, how many have said using has changed how they currently plan the paddock passes. I guess from our perspective, we've got a number of case studies that we've been working on here, and I think to your point, Emma, like we've got was it 15 or so case studies we're currently working on, and yet some of those growers have maintained those AB lines, but then a number has helped set up a change of direction, especially once you start taking into account the internal boundaries rather than just relying on the longest, straightest edge. But Godard, did you want to provide any feedback to that comment either?
Yeah, for sure. So we've got customers in US, Canada, Brazil, Western Europe, Eastern Europe, and obviously Australia. And as Ed mentioned, we've got about 16 case study growers in Australia. And he's right, not all of them are changing their plan. There's two things. One is, obviously a lot of generational information sits with the growers. This is a way to validate what has been decided before, but at the same time, look at ways it can be improved. It could be managing some of those internal boundaries and saying, okay, can I modify my farm and extract a little bit more efficiency? Or what I thought was the fence line was that actually the longest straightest edge. Does some other edge represent the longest straightest edge to minimize the number of passes in the field or minimize overlap across the whole field? So it's a stepwise process to changing an AB line. We're not suggesting do that at first, but analyze what's best for each paddock. And obviously, as you're changing machinery and acquiring newer land, this is an easy way to get set up right off the bat.
Excellent. Thank you, Godard. But yeah, I think that really does help hone in on what we're trying to bring to the table here in this introduction, build the awareness of what Verge can do, and yet also linking together that for the growers that are looking to go down this road, it is worthwhile just spending the time investing in your digital farm first, but start bringing that into Verge. I think it does help optimize that performance off from the get-go, but it's great to also have those tools highlighted that you can do a lot of that boundary creation and refinement in Verge as well, and then be able to bring that back. So there's a couple of options there for the growers to be able to work through that. So as Godard said, there will be more webinars and extension programs coming through, which will then start honing in on some of these case studies and where some of the benefits the growers have been finding over the journey of being involved with the software. But like Godard mentioned, please jump onto Verge Ag, navigate yourself, especially if you do have a machinery portal where you can sync that together. It is a really easy sign-on process, and same with just importing boundaries of the shapefile is a super easy process. So thank you all for attending, and we look forward to keeping you in the loop with future extension activities and webinars. Thank you.
Thanks, everyone. Have a good day.